Hey, welcome grade 6 to a new video. We're into a new unit on patterns in algebra, and we're going to start at PA 6-9, which is called unknown quantities. And we're going to be, hopefully by the end, writing and solving one-step equations and also solving easy two-step equations. The way we're going to do that is by converting some one-step equations. And so where we're going to start is just looking at some equations that use addition. And before we even get into numbers, etc., we're going to just start with this, with a nice little diagram. This says what equation represents this picture. And we would say, well, it's some unknown plus 2 circles is going to give us 5 circles. So then the question we're asking is how many circles are in the box? In other words, what number do you add to 2 to get 5? And hopefully we know that we get 1, 2, 3 in the box, and that will give us our answer of 5. I just wanted to point out real quick that and I think I've said this before, but the equal sign means that everything that is on the left side has to equal everything that is on the right side, because we use this thing called an equal sign, which means that both sides have to represent the same value. Okay, so the next one is equations that these represent, and again we have some unknown plus 3 equals 2, 4, 6, 8, and so we know that we're going to be adding, I should probably change the color a little bit. 2, 3, 4, 5 plus 3 will give us 8. This one's a little bit different. This is 1, 3, 5, 7, and 9 is going to equal 6 plus some number, which is going to be 3. And so that is really just the quickest way. Notice that sometimes the unknown is on the left, sometimes the unknown is on the right. It doesn't matter, so long as the left side of the equation equals the right side in terms of the quantity or the value of the number. You can pause it here real quick and move on, work in your workbook. We're on page 70. You can do number 1 and 2, and then when you finish those, you can unpause the video and pick it up again. So we can here draw a picture to solve the equation, right? So we have some unknown, so we've been using boxes, and it's plus 2, and that's going to equal 1, 2, 3, 4, 5, 6, 7, right? So the question then would be, how many circles would we put in the square to make the equation 2? In other words, what are we adding to 2 so that we can get to 7? Well, we have to add 5 plus 2 equals 7. And so you can make a model here for these two problems as well. And so here we would have 1, 2, 3, 4, 5, 6, 7 plus the unknown would equal 1, 2, 3, 4, 5, and enough space, 6, 7, 8, 9, 10, and 11. So 7 plus, and we know it's going to be 4, is going to equal 11. And this other one, we'd have 1, 2, 3, 4, 5, 6, plus some unknown is going to equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we know, hopefully we know, that in here we need 1, 2, 3, 4, 5, 6, 7, that those added together will give us 13. So the next thing that we can start talking about is writing equations to solve problems. So if we see a word problem here, we can read this and we can create a word problem or an actual equation to solve it. So here's the word problem. It says there are 10 trees in the garden. 3 of them are apple trees, and all the rest are cherry trees. So then how many cherry trees are in the garden? Now, let's just identify a couple different parts of this word problem, okay? So, first of all, this part here, this is the total number in the garden. And so 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my 10 trees in the garden. And that's going to equal, right? That's the next part. So then the next part, it says 3 of them are apple trees. So that's a number that I know because it says 3, right? And then that's going to be added to this third part where it says all the rest are cherry trees. Now it doesn't give us a value, so that's an unknown, right? So that would be my box, right? So 10 trees in the garden it's equal to 3 apple trees plus some number of cherry trees. To solve that, we know that we would need 7 cherry trees to make that equation true. And so that's how we could write an equation to solve this problem. Now, this is actually a diagram. What I could also do is just start using numbers and say, well, 10 equals 3 plus an unknown. You could write this way as well, and that will work too. In fact, that will work very well for number 3. So if you want to pause it real quick, you can work on number 3 in your workbook. There is another problem here. It says that Cindy has a box of apples. She took 2 apples from the box and 4 were left. How many apples were in the box before she removed any? Now, this is a little bit different because what we're actually going to get a chance to do is look at some subtraction here. So the equation will look a little bit different. And so what I'm going to do is I'm going to say, well, there is, it says that she has a literal box. Okay, so here's her literal box. Now, it says that she took 2 out of them and that there were 1, 2, 3, 4 left. And so this is how we could write a diagram with our equation, right? And so we would need to have these 4 in there originally, 1, 2, 3, 4, and then these 2, they get taken out because this is what's going to be getting taken out. So my original number here would end up being 6, right? Because 6 minus 2 is 4. And again, we want the left side to equal the right side, but that's kind of how we write subtraction equations. So again, this is the way that we're modeling it, right? We have the number of apples at the beginning, which is, as we said, it's unknown. She takes the 2 apples out and there are 4 apples remaining, right? And so we can actually write and solve the equation for this picture. So what we can say is, there's some unknown, we take 2 away and it's going to equal 4. And then we can say that the unknown is going to be 6. So if you want to pause it for a second, you can work on number 4 and 5. There's a couple other problems here. We have an unknown minus 3 equals 5. And so my unknown is going to equal 8. We have an unknown minus 6 is going to equal 4. And my unknown is going to equal 10. So it says now to draw a corresponding model and then solve the equation, which is just kind of going in reverse from what we just did, but I'll just do once. We have an unknown and you take out 6 and you are left with 3, 4, 5, 6, 7, 8. You're left with 9. And so what we would do then is say that the original box, there's 15 in the original box because 15 minus 6 equals 9. I'm not going to do the other ones. I'm just going to move on because there's a lot of slides yet. So we can also draw pictures and write equations for multiplication problems. So you have 2 times 3, right, which would equal 6. So you'd have 2 times an unknown, which would equal 2 unknowns. Okay. And then so we're thinking about how many circles go in the box. Well, if you sort of divvy this up into 2 boxes, like this, sorry for the crossover, but that means that you would need 6 in the one box. So 2 times 6 gives us 12. And here we have 3 times an unknown, which would give us, right, it ends up giving us 9. And so if we divide them into 3 groups, or put them into 3 even groups, then we know that you need 3 times 3 is going to equal 9, right? And here you'd have 5 times, and again, you can just split this up into 5 equal boxes, and we see that in one box you're going to need 2. Okay, and again, you can write multiplication equations from word problems. Since that Tony has 4 boxes of pairs, each box holds the same number of pairs, and he has 12 in total. And so to write that out, it would be 4 times an unknown equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can see that in one of those boxes, because if I draw one circle around here, I would get 3. All right, and so some extra problems. This is write and solve an equation for the problem. It says that Jenny used 3 eggs to bake muffins. 7 eggs remained in the carton. How many eggs were in the carton? This ends up being a subtraction question where you have your unknown and you take 3 and you're left with 7. So some number minus 3 equals 7. And so we know that that's going to be 10. Here, Bob has 9 pets. 3 of them are snakes. All the rest are iguanas. How many iguanas does he have? Well, that's some number plus 3 equals 9. And so for some reason, Bob has 6 iguanas and 3 snakes. I don't know why. I really don't. One of those things is plenty. Okay, some extra problems here about solving the equation. You can pause it. You can work through those on your own real quick. I'm just got to keep moving on. Some more word problems, which are worthwhile pausing and working on them. Okay, I'm going to move on. Let's see to this one about checking if an equation is true or false, because this one gets us right into number 6 on the on page 71. So here on the left side, we have 3 times 5, and the claim is that 3 times 5 equals 6 plus 7. Well, 6 plus 7 is 13, and 3 times 5 is 15, and so we would say that is not equal. They are false. But there are ways that we can look at these things where it says, which of these 2 numerical expressions have the same value? Well, 5 plus 3 is 8, that's 6, and that's 8. So these 2 have the same numerical value. And so to write an equation to say that they're equal, we would say that 5 plus 3 equals 2 times 4. And so you should be able to look at problems to say, okay, we're going to find the missing number for here that makes all 3 expressions equal. And so this one, you can just start guess and check if you would like, right? So it's not 1s because 1 plus 6 is 7, but 4 times 1 is 4, so that's not good. But if we use 2 for all of these, 2 plus 6 is 8, 4 times 2 is 8, 10 minus 2 is 8. So that's how we check the truthfulness. Okay. Now, what that gets us into is using variables. And so in these equations so far, the variables have been expressed with boxes, but we could use a letter, which we've used in the past, to say x plus 5 equals 6. And so on the last page, which is page 72, you are asked to look at equations that use variables and solve the equations, right? So for example, instead of a box plus 3 equaling 8, it's x plus 3 equals 8. And we can say that, well, x is not 11, sorry, that would be subtraction. We can say that x equals 5 because 5 plus 3 is 8. Here you have 9 plus x equals 11. X is going to equal 2. Here 13 is equal to some number, or x plus 3. We'll say that x is equal to 10. And again, you can read a word problem and use a variable to solve these problems because that's what you're going to need to do as well. Since the Dory has 21 red and green balloons, 13 of them are red. How many are green? So I'm going to say that's some number plus 13 equals 21, okay? This x represents the number of green balloons, this one's red, and then this is the total of red and green balloons. And so again, there's some practice there. You can pause it if you'd like to practice them before you get into the workbook, or you can get into the workbook problems, right? Now this one, we sometimes have to do 2-steppers. And what I mean by 2-steppers is we say, well, so x plus 3 is going to equal, and I actually have to do this multiplication first. And now I get to a simple 1-step equation where I can just say that x is equal to 7. So you have to do sometimes the stuff on one side of the equation first. So that's like, for here you would say x plus 5 equals 12, and then x is going to equal 7 because 7 plus 5 equals 12. You can do those ones on your own. Okay, I'm literally almost out of time. This is the practice if you haven't been doing the stuff. It is Unknown Quantities, page 70 to 72. Thanks for watching. Have a great day.